Hello, so today we're going to be talking about completing the square. This is module 16.5, when you have an ax squared plus bx plus c equals 0. The only new thing is going to be a number in front of the a, in front of the x, which is an a, and that's going to change your whole formula. So if you take a look here, completing the square when a is a perfect square. So when a is a perfect square, like 4, 9, 16, 25, 36, it makes it a lot easier and you don't have to do anything to the actual equation. So when a is a perfect square, completing the square is simpler than in other cases. Consider the case involving the algebra tiles. We don't need to worry about algebra tiles. So basically, our equation for our c is going to be b squared divided by 4a. So just like for example 1, your a is going to be your 4, your b is 8, and you don't have a c. So your a, it must be a perfect square. And then this is the equation that you're going to be writing, is your c equals b squared divided by 4a. So your b is 8, so it's going to be 8 squared divided by 4 times a, which is 4, so 16. So 64 divided by 16 equals 4. So now what we're going to have to do is add this to both sides of the equation. That's why we have the plus 4 plus 4. And then we're left with 4x squared plus 8x plus 4 equals 25. Now what you did is you just created a perfect square trinomial right here. So we're going to solve it just like you've been doing. So this is a perfect square trinomial. So you're going to take this, so you can actually find the equation. So it's going to be 2x plus 2 squared equals 25. And then to get rid of this squared up here, we have to take the square root of both sides, which would be 2x plus 2 equals the positive and negative 5. And then this breaks up into two different equations. So 2x plus 2 equals 5, and 2x plus 2 equals negative 5. And then you just solve for x, and we're left with x equals 3 over 2, and x equals negative 7 over 2. And those are going to be your answers there. So we're going to go ahead and do number 1 on page 599 together. So we have a 9x squared plus 30x equals 16. I always like to leave space when I know I'm completing the square, because I know I have to add something to both sides. So we're going to use our old formula, b squared divided by 4a. So our b right now is 30. So we're going to do 30 squared divided by 4 times our a is 9. So 30 squared is 900. 4 times 9 is 36. So 900 divided by 36 is 25. So what we're going to have to do is we're going to add this to both sides. So here's plus 25 plus 25. So now this right here is a perfect square trinomial because your 9 is a perfect square. So this is going to break up into 3x plus 5 squared equals 16 plus 25 is 41. So now we have to get rid of that squared by taking the square root of both sides. So now 3x plus 5 equals positive and negative 41. Now if you notice, this 41 is not a perfect square. Positive and negative square root of 41. So that is not a perfect square. It's not really, and we don't really want to deal with fractions, so we're just going to leave it as square root of 41. So when we break this up into two different parts, it's going to be 3x plus 5 equals square root of 41, and 3x plus 5 equals negative square root of 41. So now all we have to do is just solve this like we've been doing. So minus 5 minus 5. So 3x equals square root of 41 minus 5. And then divide by 3, divide by 3. So then we're left with x equals square root of 41 minus 5 divided by 3. Now the next one, we're going to do the same exact thing, except it's going to be a negative 41. So we're going to minus 5, minus 5. So 3x equals negative square root of 41. Sorry. Negative 41 minus 5. Yeah. So 3x plus 5. And then we're going to divide by 3, divide by 3. So it's going to be x equals negative square root of 41 minus 5 divided by 3. Now, if you want to be lazy, like I know Dayton's probably going to do this, you're going to have to go, you could just do x equals positive and negative square root of 41 minus 5 divided by 3. And that's fine. So instead of having the two equations, if you just do the positive and negative, you're good there. All right, so now we have to learn about completing the square when a is not a perfect square. So when a is not a perfect square, all you're going to have to do is multiply the whole equation to create a perfect square for a. All right, so for example, you have the 2x squared minus 6x equals 5. Now notice that a right here is not a perfect square. But what could we multiply to both sides to create a perfect square? I'm going to multiply everything by 2 to create a 4, which is a perfect square. So now all we're going to do is just have 4x squared minus 12x. I'm going to leave a spot for my completing the square, equals 2 times 5 is 10. So make sure you distribute this to every one of these terms throughout the whole equation. So now we're going to use our same formula. So it's going to be our b squared divided by 4a. Our b is negative 12. Negative 12 squared, 144. 4 times 4 is 16. So we're going to add 9 to both sides. So we're going to add 9. We're going to add 9. So now on the right side, this is going to be equals 19. And on the left side, when we take this perfect square trinomial, and notice that that is a negative sign, so it's going to be 2x minus 3 squared equals 19. So now all we're going to have to do is just solve it like we've been doing. So we need to get rid of that squared. So we're going to take the square root of both sides. 2x minus 3 equals positive and negative square root of 19. So this is going to break up into two equations. 2x minus 3 equals square root of 19, and 2x minus 3 equals negative square root of 19. And then we're just going to solve it. So plus 3, 2x equals square root of 19 plus 3. And then we're going to divide by 2, divide by 2. So this is one of your answers. X equals square root of 19 plus 3 divided by 2. Now on this side, we're going to add 3. So 2x equals negative square root of 19 plus 3. And then divide by 2, divide by 2. And that's going to be your answer there. Now if you want to take the easy way, you can just write x equals positive and negative square root of 19 plus 3. Make sure that 3 is not underneath the radical sign. And then divided by 2. And that could be your answer for that. So basically that second part, all you have to do is just multiply something to the whole equation to create a square for a, to create a perfect square. Now we can go ahead and do, we'll do number 4 on our homework in the guided practice on page 599. So we're going to have 3x squared plus 8x equals 5. Now, if you notice that a is not a perfect square, but we all know that we can multiply everything by 3 to create a perfect square. So we're going to go 9x squared plus 24x equals 15. Now we are going to complete the square by doing our b squared divided by 4a. So our b is 24. So 24 squared, 576, divided by 9 times 4, 36, is 16. So 16. So we're going to add 16 to both sides. So that was completing the square. Now 15 plus 16 is 31. And then we know that this is a perfect square trinomial. They're both positive. So we're going to have a 3x plus 4 squared equals 31. So 3x plus 4 squared equals 31. So now we're going to solve it like we've been doing. Take the square root of both sides. So now we're left with 3x plus 4 equals the positive and negative square root of 31. So we're going to write this out into two equations. 3x plus 4 equals square root of 31. 3x plus 4 equals negative square root of 31. Then just solve it. Minus 4 equals square root of 31 minus 4 divided by 3. So that is your answer. X equals square root of 31 minus 4 divided by 3. Then this side, minus 4. 3x equals negative square root of 31 minus 4 divided by 3. Or you could just write x equals positive and negative, square root of 31 minus 4 divided by 3. All right, that's about all I have. If you have any questions, please reach out to me and I'll respond to you as soon as I can through email. And I hope you're having a great day and have fun.